Welcome to Chapter 17, 17.6, IV flow rate adjustments and titrated medications. Alright, so for the last half of this section, the lecture notes will need to be filled out independently by you after reading this section, so please make sure to do that. Alright, so IV flow rates of heparin and other medications may need to be adjusted. The goal is to administer the least amount of medication to achieve the desired effect. The amount of medication you need to achieve the desired effect varies. So for the first rule, to calculate a weight based on intravenous rate adjustment, 1. Determine the rate change needed using the current infusion rate, protocol result, and the patient's weight. 2. Subtract the rate adjustment from the current IV rate. And lastly, find the flow rate based upon weight per time using the procedure checklist 17.3 from page 520 of your textbook. Alright, so for the first example, find the hourly flow rate adjustment using the heparin protocol in table 17.1 on page 514. We're going to be using the proportion method. Alright, so the current infusion rate is 25.2 milliliters per hour, and the APTT protocol result was 120 seconds. The patient weighs 70 kilograms. Alright, so if you review the protocol, we will note that the rate should be decreased by 2 units per kg per H. Okay, so we know, let's see, the rate should be decreased by 2 units per kilogram per hour. Alright, and please note that this information can be found on page 514. It's in that chart. But remember that the chart that they gave us was only to be used for the textbook, not actually to be applied in practice. So the chart you'll be getting in practice will depend on where you are working. Alright, so we know this from the chart. Also from the chart, we know that the initial rate for heparin is 18 units per kilogram per hour. Once again, both of these pieces of information are read off of that chart on page 514. Alright, so what we're going to do is subtract the rate adjustment from the current rate. So, go ahead, we'll have 18 units per kilogram per hour. I'm going to subtract away from that the 2 units per kilogram per hour, which will give us 16 units per kilogram per hour. Alright, so now what we're going to do is find the flow rate for find flow rate. Alright, so first thing we got to do is check the information we have and make sure it's in the correct units. Okay, so what do we know? Well, we know that the patient is 780 kilograms, not 780, 70 kilograms, excuse me. So patient weight is 70 kilograms. And what else do we know? Well, we know the dose on hand, which is 50 units per ml. Once again, this part, 50 units per ml. This is also found, let me do that in the same color, found in the chart. Okay, so a lot of this is referring back to that chart that we're using. Alright, so we've gone ahead and found that. We don't need to convert any of these. They are in the correct units. So let's go ahead and calculate. Alright, so remember we're trying to find the hourly flow rate adjustment. So last step, we're going to do the calculation. So let's calculate the desired dose. We're going to multiply the weight by the ordered dose. Alright, so we have, the weight is 70 kilograms. Oops, 70, I don't know where 17 came from. 70 kilograms times, and the desired dose, right over here, 16 units per kilogram per hour. We can go ahead and cancel out the kilogram units. And this simplifies out to being 1,120 units per hour. Alright, so we have found D, the desired dose. So now we're going to go ahead and calculate the flow rate. A lot of steps in this one. Alright, and calculating the flow rate, we're going to set up our proportion, which remember is H over Q equals D over A. The dose on hand we have is the 50 units. All over the Q value, or the unit there, which is going to be 1 milliliter, equal to, and the desired dose is 1,120 units per hour, all over A, which is what we're trying to find. Going ahead and canceling any of the common units out. Okay, and we can cross multiply. We'll get 50A equals 1,120 milliliters per hour. Dividing both sides by 50, we'll get A equals 22.4 milliliters per hour. And there we have the flow rate is 22.4 milliliters per hour, period. Okay, so let's keep going. Many critical care IV medication dosages are also titrated. Alright, I'm changing those. The uploaded note version should be in your LaLima if you already haven't printed it out yet. Based on the effect of the patient's hemodynamics, forces of the blood flow, or heart rhythm, page 525. So, the Rule 17.8 for safe titration. 1. Calculate the starting flow rate using procedure checklist 17.3. Then calculate the minimum allowable flow rate using the procedure checklist. Calculate maximum allowable flow rate using procedure checklist. Begin infusion at the starting flow rate. Titrate the dosage based on patient response. Do not exceed maximum rate. And if your response exceeds the prescribed parameters of the minimum dose, discontinue the infusion rate and notify the AP. Alright, so let's take a look at an example for this. So what we have ordered is dopamine 400 milligrams in 500 milliliters normal saline to infuse at 20 microgram per kilogram per minute IV to keep systolic blood pressure greater than 90. Keep heart rate less than 100. Start at 5 micrograms per kilogram per minute and titrate according to blood pressure and heart rate. You are using an infusion pump and the patient weighs 80 kilograms. We're asked to solve using dimensional analysis. Alright, so first step, we're going to go ahead and look at all the information we have, see if we have to convert anything as usual. So what do we have? Well, we know the patient weighs is 80 kilograms. Right there. And let's see, we have the dose on hand is in milligrams and the ordered dose is in micrograms. Milligrams versus micrograms. So we're going to have to go ahead and convert from milligrams, not milliliters, milligrams to micrograms. So let's go ahead and start that. We can set up our proportion. Cross multiplying, we'll end up with 1 milligram times x equals 400,000 micrograms times milligrams. We can cancel out the milligrams. And we'll get X equals 400,000 micrograms. And we know that we had 400 milligrams in 500 milliliters, which we have right up here. Which now we know that 400 milligrams is equal to 400,000 micrograms. So we can write that over 500 milliliters. And we can actually simplify this to 800 micrograms over 1 milliliter. And right there we have the dose on hand, H, over the dosage unit, Q. Alright, so what we need to now find is the desired dose. Okay, so to find the desired dose, we're going to go ahead and multiply the 5 micrograms per kilogram micrograms per kilogram per minute times the patient's weight, 80 kilograms, to find our desired dose. And remember, we got the 5 micrograms right over here. Okay, when we do that, the kilograms cancel out, and we can simplify this to get 400 micrograms per minute is the desired dose, D. Let me just change that to yellow since everything else is in yellow. Okay. There's a slight problem here though, and it is the units that our desired dose are in. Let me change my pen real quick. Alright, so the desired dose, let me write this in pen actually. So desired dose, D, is in micrograms per minute. However, we need to determine micrograms per hour. So we're going to have to go ahead and convert that. Lots of conversion. Okay, so let's see. We have the 400 micrograms per minute. We'll times that by the conversion factor of 60 minutes in 1 hour. Remember, this is our dosage. Dosage unit D. And that's going to go ahead and equal, let's see, the minutes cancel out. And we are left with 24,000 micrograms per hour, which we needed. So we converted from the minutes to the hour. So our desired dose D is now in the correct units of micrograms per hour. Okay, now we can finally calculate the flow rate. Alright, so calculating the flow rate, we're going to do the same proportion. HQ equals D over A. H is here, the 800 micrograms, all over Q, 1 milliliter, equals to D, desired dose, 24,000 micrograms per hour, all over A, what we are trying to find, the amount to administer. Okay, we can cancel out some of the units there. Now let's go ahead and cross multiply. So A times 800 equals 24,000 milliliters per hour, dividing both sides by 800. Those zeros cancel. We are left with A equals 30 milliliters per hour. And there we have the starting flow rate. Starting flow rate is 30 milliliters per hour, period. Okay. Alright, and so the rest of the section is from your reading. So please email me if you have any questions.